Hello, this is my coursework. My coursework aim is to accomplish text-to-image progress, and this thing is my progress on the GitHub published on that. And the first step is input the sentence, and second step is trained LSTM module to recognize the type of sentence. And I've designed 4 types: animal, landscape, portrait, and others. And going to next type is correct the wrong words in the sentence if it has, and by using the fuzzy match. And the next is the corresponding agent will enhance the sentence which you input. The final step is generate image and provide the CRIP score. CRIP score is one of criteria of text image. That's the process of my program. So we have a look my model of STM, and this file is designed as LSTM module, and is trained. And for instance, if you input the sentence "a cute cat under the table," and it should belong to animal, and a man sitting on a chair, it should belong to portrait. So we have a look. The first step is load the data set. Load this is the data set, this site, and I collect approximately 100,000 items in this site, and each row has one sentence and the kind. Like this, a gorgeous woman sitting around the river, and it belongs to portrait, and this LSTM will learn it. The next step is the data pre-preparing, and the third is build the LSTM module, and set strap out is the 0.5. And the final is compile this module and train this module, and the final step is save this module and tokenize. So after training this LSTM, so it should recognize this sentence and take it to recognize it is correct kind. And the next step is test the trained module is accuracy. To check it, so check the accuracy of the trained module. One is load the saved module, and node token, and define the map, and it should be 100% same as the training. And define the predicting function, and it's after that the load the test data site is similar as the trained data site, and each row has the sentence and its type. So just final steps, just check it is after prediction, and have the labels and check it is same, so correct. It's not same, so incorrect. So I've checked this module, so the accuracy of this module is 89% of 1000 samples. The next step is use if it has some like it shows in this progress map, it has some of the wrong words in this sentence. We use fuzzy match to correct it. So this file is fuzzy matching to correct erroneous text in the corresponding category. And fourth step is load the keywords. The keywords I have designed 3 keywords. One is animal, landscape, and portraits JSON file, and includes this shows that it includes lots of keywords in the animal kind types. But I didn't design the others because I focus on those three types. So other keywords belong to others. Yes. And also, next up is character spelling. So inputs the label like animal, poultry, landscape. Then the sentence, the original sentence, and which you input the sentence and cutoff is fuzzy matching threshold. Actually, the lower the false, if you give the lower cutoff threshold value, it will have the stronger tolerance. So if the label, so I didn't design the other JSON files. So if label echo others, so just directly return the sentence. If it belongs to others, so it belongs to animal, landscape, and portrait. If we go into the next type, and it will find find the keywords, and transfer the sentence into lowercase and match in the keywords JSON and find it. And if you have false, correct it, and final step just join together. So this is the sample. We have a look. If label is landscape, this provided it should provided by the LSTM module. Just for example, showing the example. So I just gave the label. So the original sentence is a giant cliff is rumbles near the sea. So after fix, it should be corrected, and we can see that correct sentence is a giant cliff near the sea. It works. So this is the fuzzy match by fuzzy match correcting the wrong words in the sentence. And we can have a look. The next is the agent implement. And we know that where I designed 4 different kinds of types. So we have 4 different kinds of agent. Each one has the special enhancing functions. The agent, if the LSTM model recognizes the type of sentence and after corrected the wrong words, check the wrong words, so it's going to use the corresponding agent to enhances the sentence which you input. So this is the base agent, and every agent just inherits it. So the enhanced animal agent, I've designed some effects like the environment and actions will random. It will choose randomly. So from those words, sentence. Also, same as the portrait agent, just intensify characteristic emotion and position and mood. So you can see that expressions, lighting, and accessories. In the landscape agent, add more details like the time of day and the weather climb and the region elements. The next is the other agent. Other agent is quite abstract because it's except from the animal landscape portrait, it's just struck off. So I just intensify the style by using abstract descriptions like the style, the lighting, the perspective. Yes. Finally, after it will this is just return the corresponding agent according to the labels. If you give the label, it will return the corresponding agent. And this is a sample. And the label is the portrait, and promote it should be the sentence you input. So I just showing this sample. So there, it's portrait a young woman, and we have a look how it works. So a young woman is give me the enhanced sentence. It's a young woman looking confidently into the camera in a moody setting, wearing a vintage hat. So that's my agent how it works. Next type is the text to image file. In this file, I just rent an API from DeepAI just for this final step for generating image, because my own computer can't have that computing ability, and it's so big the module. So I just use the API to accomplish the final step. So this is I just use I'll say API my personal AI key and just only valid 4 months because I just rent 4 months. And the final step is it gives the sentence. It will generate the image, and I've designed the code to provide the link of it and save it on in the local computer. So I've introduced all of my works. So we have a run module. This run module includes all the steps together. Let me show you how it works. My program. The first one is just input the sentence. So there has a word that just received sentence. Second is recognize the category. So label is predict task per mode. So this predict this method is from the STM module, and it inputs the sentence, and the trained STS module will recognize this sentence belongs to which category, and then printed the category of this sentence. Third is fuzzy match for correcting the incorrect words. And 4 is using corresponding agent to enhance the promote. So if you recognize the portrait, it will use the portrait agent to enhance the sentence which you input. And generates the image, use the API to generate the image. And final step is the CLIP score. It will provide CLIP score and show the quality of the image. I've shown you the CLIP score as the Python file, and this file is shows how to calculate the CLIP score, and it provides the image and provides the text description. It will automatically return the CLIP score. That's it. We have a look. We have this is one of my this link is one of my image links. Let's just use the link style, and it's where the image and the text of this link image, and the return score. We have a look. So it will go to this URL and save it, and save it to the program, and see the text and your image CLIP score, and the score is the 0.2354562. Yeah. So we're back to the run module. This is all steps together. So let me show you how it works. I'll run it. It will load the LSTM I trained. So I already got one. So I skipped the training progress because it takes a long time. Just show so I have use my I saved the module, so it loads successfully and input sentence, and simply there's a girl sitting a child. It will recognize the sentence is the portrait is correct, and the sentence corrected by fuzzy matching is nothing wrong in this sentence, so it's just directly return the original sentence. And after enhance agent, it give me a girl sitting on the chair with a similar expression against a dark backdrop in elegant clothing. So this saves the image and the link. We have a look the link of this image. It's the image. And the CLIP score is the 0.29. Let's try some with wrong words. If I input a wrong word like panda, it's wrong words. A panda sitting on a tree. So it will recognize this sentence is the animal, and it will go into the animal JSON uh, JSON document with check the keywords and correct it. So correct the sentence is a panda. It works very much. A panda sitting on a tree, and after the agent, a panda sitting on a tree roaring loudly on snowy terrain. So the link of this image, let me have a look. It's nice, isn't it? And the CLP score is 0.32. So that's all of my works in this program. Also, I've designed a spreadsheet show this show my program and a questionnaire with the other people's. So this is my friends. I invite my friends to give some talks and to take they will give me the satisfaction of the image and also have the CLP score, and those are generated images. So these are the tags. So we can see that average satisfaction is the 8.75, and the CLP score is 0.2875. It's quite nice. So that's it. That's all of my works. Next up, I'm going to introduce the drawback of this program. At first, when I input a relatively simple sentence, like such as a bird, a cliff, a woman, the LSTM module often fails to accurately classify which category the sentence belongs to. And so, this is mainly due to the limited generalization ability of the LSTM module. To address this, I enriched the train dataset, increased its diversity, kind of like that. Like a waterfall belongs to landscape, a desert, landscape, a cat, animal, and a woman portrait, kind of like that. It's really simple words, and it's performed better after training. And the second issue, if a sentence includes multiple keywords, it requires manual identification first. We have a look there. The cute boy sitting on the rooftop. A boy belongs to portrait type, and rooftop belongs to the landscape type. So it requires manual identification first. This progress is so time consuming, and this step directly affects the performance of the program. So a semi-automated labeling system will be the better choice, and it's ultimately labeling and I checked later. It will be nice. It saves lots of time. So overall, this project successfully achieved the process of converting text to image by integrating LSTM module for text classification and using the fuzzy match to correct words in the sentence and enhance the sentence through corresponding agents and have spatial identify words. And in the end, if given more time, I would like to explore a different type of module and adopt a larger and more diverse training dataset. Also, I would like to adjust the learning rate. Thanks for your time. Have a good day.